Assalamu alaikum wa rahmatullahi wa barakatuhu. Friends, welcome back to my channel. In last video number 1205, I repaired this power supply. It is 12 volt 10 ampere power supply. The problem in this power supply that IC here UC3842 was damaged. It is the best technique when we are repairing UC3842 43, 44, 45 base power supplies. We must check VCC voltage. Then the next, reference voltage. When I tested, I found 54 volt on pin number 7. Pin number 8, just few millivolt were there. I received too many comments from my viewers. I will read that comments and I will explain why there were 54 volt in this power supply. First comment here, hi Haseeb, after you repair, how much voltage to ground you get at pin number 5 and 8 when energized? That means if the IC is good, how much voltage will there at pin number 8? I will explain pin number 7 and I will explain pin number 8. If you don't have good experience in electronics, never do this experiment. Never try to repair because here are live voltage. Always take care for the safety. DC voltage. In initial stage, it will take 16 volt from this capacitor. I will explain in detail. And then from transformer, bias winding, auxiliary winding, VCC winding, it is receiving 11.64 volt. There are two channels of current, one from this capacitor, the second from this transformer. This time we are receiving voltage from this transformer that are 11.6 volt. 1842, 2842, 3842, 1843 UC, 2843, 3843, 1844, 2844, 3844, 1845, 2845, 3845. These all ICs behave same. Just only there is difference in VCC voltage at pin number 7. But reference voltage are same even at 3846. At pin number 8, 4.995. These are standard voltage, 5 volt. If any IC is not providing 5 volt, that means that IC is not good. Because within this IC there is a reference good circuit. That block within the IC will monitor voltage all the time. If any time the voltage are less than 5 volt, 4.995. If the voltage are less than 5 volt, this IC will go in disable state. Then thank you for sharing. Peace be upon you. I have power supply. The cooling fan used to work. That is not related to this video. I will discuss separately. Thank you so much. God bless you. I am also thankful for your comment. There is 54 volt at the legs 5 and 7. Of the PWM IC. You only change the IC, there should be still 54 volt. This voltage is too high or not? I am not able to understand the situation. No problem. Why there are 54 volts? I will note down the questions. Then excellent, Mr. Haseeb. Thank you. What do you think caused the failure of IC? Why IC damaged? Then sir, make some video about Dell monitor SMPS repair videos. Okay, I will try. Then good morning sir, camera is zoom out too much. This is biggest headache for me because I am not good in videography or I am not good in pictures. Even I don't use my camera to take selfie. I am far away from this subject. So this is reason most of the time the video is zoomed out. There is blur, defocusing, like that. But no problem. Still I am trying to fix this problem, and I hope someday I will make it better. How do you verify VCC rectifiers? The next question, why was the input voltage 54 volt but no other parts damaged? I don't see how voltage was 54 volt. Where was that voltage coming from? I will explain by making a circuit diagram and by checking practical circuits. Then I also have same doubt. Okay, then same question came to my mind. If there is 54 volt reaching to VCC pin, then why the new IC not damaged? Please, Mr. Muhammad, can you explain? Yes, sure. Then the next, notice that this voltage is on no load. Since the circuit was open, it is normal to reach such voltage under no load. In our case, the load is IC. Yes, this is right. Exactly, this is a good comment here. Then G4ZBK7CT, any voltage will not double or triple even with no load. You are just wrong. Delete your useless bad post now. I don't know he is replying to this upper comment or he is saying to me. If he is replying to this comment that these voltages are with no load, then I think this comment is somewhat not good. I respect for every opinion of my viewer. So if he is saying about my video, so my video is perfect and 54 volt are normal. Electronic components are working with smoke. When some smoke come out, they no longer functioning. Yes, it is the reality of the components. If any component damaged with smoke, without smoke, it is the same. When its junction, if it is semiconductor, when it loses its specifications, then it is no furthermore. The semiconductors are much sensitive. Then the next question, electrical characteristics section says VCC 15 volt and reference section of the datasheet says VCC 12 to 25 volt. I don't know what is the VCC in 3842 IC. This is input section. After EMI filter, the voltage are reaching to this bridge rectifier, positive negative terminal. We received positive voltage and negative voltage from where? From this bridge rectifier, that is here. These voltage are reaching to this main capacitor. Here is capacitor. Then these negative voltage are reaching to this point. From here to here there is a resistor, this one, that is this resistor. It is connected between source pin of the MOSFET and ground, and positive voltage from here, these are reaching to transformer primary winding, one end. Here is MOSFET. At the source pin, here is our current sense. This end is connected here. This capacitor negative terminal. So current will flow in this channel when this MOSFET is on. If this MOSFET is off, that means there is no current here in this primary winding and there will no current in secondary winding. same time we have third winding here, that is called auxiliary winding. One end of this winding is connected directly to ground, that is auxiliary winding, bias winding, VCC winding. That means if this transformer primary winding is off, there is no current flow in this channel until it will receive any pulse to turn on this gate. To provide drive signal here, gate drive components here. These components from here, resistor, and it is coming from pin number 6 of UC3842. 3842, 3842, 43, 44, 45. These all ICs are approximately similar. This is pin number 6. This IC needs biasing voltage. For initial startup, here are two resistors in parallel, 200 kilo ohms, 200 kilo ohms, that are connected between these 2 points, and it is positive terminal of the main capacitor. Then from here to here, the second resistor, that's this one, 43K, 4330s. That means 200K, 200K, two resistors in parallel. The RT will 100K, equivalent resistor. $43K. It is connected to pin number 7 of this IC. Two resistors in parallel, 200, 200. Resistor in parallel, 100K, and this 43K, for 143K resistor connected to pin number 7 of this IC. This is pin number 7. Pin number 7, here is a capacitor, that is this ceramic capacitor. It is to remove ripples for filtration. If you see this line here, from here to this point, here is a jumper, this J2, and it is reaching to capacitor negative terminal. That means at pin number 7 we have this capacitor and it is connected to ground line. Next component here, this one. This is polarized capacitor. Normally it is 50 volt capacitor, but I don't know why in this circuit here is 100 microfarad 35 volt. Almost every power supply uses 50 volt. That means in parallel to this ceramic capacitor, this capacitor, 100 microfarad 35 volt. If I will simplify this circuit, 143K resistor, that is this one, is connected to pin number 7 of this IC, and there is a capacitor connected to ground. Ripple removing capacitor is in parallel. Here we applied 310, 330 volt DC. Because voltage applied here at line terminal are rectified and peak voltage are stored here, 220 here or 230 here, 330 here. AC voltage multiply with 1.414. When we connected to this higher voltage, and this capacitor is 35 volt DC, That means it will start charging. When it will start charging, this is point to be understood. Here is current and here are voltage. Let's see 3842. When we connect here and this capacitor is at zero potential, that means pin number 7 of this IC is also at the same potential. When there are 0 volt, this IC is off. Current here will flow. How much current will flow? V divided by R. It will depend on the resistor value. If resistor value is too high, the low current, minimum current will flow. But in this case, 310 divided by 143, 2.23 milliampere. 2.23 milliampere current is flowing in this channel to charge this capacitor. When the capacitor will start to elevating the voltage, the current will decrease. But normally we can say 2.3 milliampere short circuit current will flow in this channel. Capacitor is charging. This IC will receive that rising voltage at this pin. Normally 0.3 milliampere, 300 micro to 500 micro, 0.3 milliampere to 0.5 milliampere maximum is standby current. This IC will not work. The voltage are increasing until it will reach at 16 volt. When this capacitor will obtain 16 volt, that means the IC is also receiving 16 volt. That time the internal voltage comparator, VCC comparator, will turn on this IC. Before this, it was receiving 0.3 milliampere. Now the capacitor is charged at 16 volt. At 16 volt, this IC turned on. When it turned on, it will start to consume 17 milliampere. We can see at this current it started. The IC is biased up and its chip is now consuming 0.3 milliampere current. That is very low current. And this channel is providing 2.23 milliampere current in this path. When this IC started switching to drive this transistor, this MOSFET, that time it is consuming 17 milliampere current. We are receiving 2.23 and it needs 17 milliampere. From where it will receive? It will receive current from this capacitor. When this capacitor will start to discharge, its voltage level will start to decrease. When the voltage level will decrease until 8 volt, this IC will turn off again. It started switching. This is a specific time. It will depend on the microfarad of this capacitor. When it started switching, it is switching this transformer. When it will switch, we will receive output voltage here. Same time it will generate voltage in this VCC winding. In this VCC winding, this end is connected here to this rectifier. That is this one. This is D7 VCC rectifier transformer. This winding end will produce voltage to this rectifier. Then there is a resistor here that is in series with this one. It is VCC setting resistor. This resistor is used to adjust the VCC voltage. I can say it is jumping here, then this voltage, this resistor and this voltage are reaching here. When it started switching in this portion from 16 to downward, capacitor is discharging. If this transformer will produce output, that time it will receive smooth running voltage, enough current that is above than 17 milliampere, above than the required current of this IC. That time this capacitor will maintain voltage. Otherwise it will keep discharging until 8 volt. If this circuit is failed due to any reason, IC damaged, this damaged, whatsoever, it will not receive a required voltage at this capacitor. So this capacitor will discharge. When it will discharge, this IC will stop switching and here it will turn off. Here it was receiving 16 milliampere, but now again when it will turn off, IC is off, the capacitor will start again to charge at this current and IC will start to consume this current. We can say this IC will change from 0.3 milliampere to 17 milliampere for powering on, and when it is going in off state, the current will decrease to this value. Now this is the working phenomena of this IC. If this circuit is working good, that time we will receive voltage from this VCC winding. What happened here now? When this IC was damaged, here is polar capacitor. All these capacitors are polarity sensitive and voltage value sensitive because these are polarized capacitors. In forward condition, we apply positive voltage at positive, ground at ground. If the voltage will reach at this level 35 volt, until this voltage value it will remain safe. Normally the voltage value is considered 20% to 30% less than this value. That means the circuit will work around 20 to 25 volt, but the maximum voltage value 35 volt. If any circuit is feeding more current, there is potential difference. Why? This capacitor is 330 volt capacitor here now. Basically it is 400 volt, but the circuit that is feeding current from here, that is maintaining 330 volt at this line, and this capacitor is now just 35 volt. In case this IC is damaged, there is potential difference. Here is 310 volt, 330 volt DC at this rail. If this circuit is not consuming current, when it was consuming, it was requiring 17 milliampere for powering on, but normally this will not provide enough current because it is providing just only 2.23 milliampere. That means it is controlling the current, but if this load is off, this IC is damaged. It has 36 volt clamping diode inside this IC. If this IC is now failed, when the voltage value will exceed than 36 volt, that time its internal clamper diode will start functioning and it will keep discharging the voltage, this current. But maybe at specific limit or due to 100 microfarad value, maybe this diode is damaged. When it is damaged, its internal body will damage again. Let's suppose now this IC is disconnected from the circuit. Even it is removed or it is damaged. If it is short circuit, that is different condition. That time it will not allow to produce voltage to this circuit. That time pin number 5 is connected to ground. If this IC is short circuit, it will allow all 2.3 milliampere current to the ground. Current flowing here will keep discharging. Normally it is blocking inside. That is short circuit condition. That time we will not find voltage here, or maybe 1 volt or less than 1 volt will there on this capacitor. But if this IC is damaged, this is second condition. What will happen now? Now due to potential difference, when we are feeding current here because there is no consumption here. Before this, at 16 volt, this IC was dropping the voltage value here, but now the voltage are increasing. When it will increase approximately 10 to 20% above than the rated value of this capacitor, its dielectric will become leaky, it will become weak, so it will behave like a resistor. This capacitor now will act as a resistor. If this current is low, that time it will keep discharging and its internal temperature will start to build up. If this current is high, that time it will blast. But due to this high value resistor, it will keep discharging the voltage here. When I was repairing that power supply, the same time, after recording that video, I received comment from my viewer. He is facing the same problem.
ال VCC صار رجعت شغلت ال VCC 70 وما ظل بيرف ما ظل شيء يعني VCC طلع.
This viewer was facing the same problem. His circuit was 70 volt. In my case 54 volt. Why? Because the capacitor value is 35 volt. In his circuit the capacitor value was 50 microfarad and voltage were 70 volt. This IC damaged, it will not make a load on this path. That time this capacitor will keep charging, but it will act as a resistor. Its dielectric will not hold the charge, it will start to leak the current. When current is flowing, its internal dielectric temperature will increase. If the current is somewhat high, that will cause to blast this capacitor. Because current is being controlled, that's why it will not blast. We will find high value voltage here. Let's suppose if I remove this capacitor here and I place here 400 volt capacitor, that time it will store 400 volt because dielectric of 400 volt will deal with 400 volt. This capacitor can deal up to 50 volt because it is 35 volt plus 20%, 30%, and then its limit is bypassed. This question, why this IC damaged? Because these are semiconductor components. There are linear ICs inside. There are current controlling components. Any misbehavior of the circuit, any ringing effect in the circuit, any spike here, maybe that spike is not stopped by EMI, that will directly impact on this IC. Any ringing from this side, in this path, in this path, that will damage this IC. When it is working good, we will receive 11.5 volt. Now I will remove IC and we will verify voltage again on this capacitor, and then I will install 400 volt capacitor and we will check that. If this resistor is not present, it is not controlling current. In fraction of seconds, this capacitor will blast. I remove this IC now and I will check voltage on pin number 7 now. DC voltage 333 volt on the main capacitor. This is ground line. Pin number 7, 54.7 volt. This time this capacitor is discharging and it will not increase than this level until the capacitor is damaged permanently. Might be at specific limit it will damage permanently because its dielectric will make short circuit. Its insulation between positive and negative terminal will finish. That time it will damage permanently. Always discharge this capacitor because it is holding charge. Yes, it's good. The second question, VCC rectifier checking. This is VCC pin and we have VCC rectifier here, this winding and winding this end is connected to ground. In diode mode, if I will connect black lead at cathode, red lead at anode, it will give forward voltage of this resistor, of this diode. This is cathode, this is anode, 0.537. So this diode is good. What will happen if I will reverse the leads? We connected red lead at cathode, black lead at anode, but in parallel there is another circuit. This is reverse biased. Move this red lead here and we are reaching to this capacitor. Move this black lead here, we are reaching to negative terminal of this capacitor. That means if in reverse polarity we connect leads here, it will start to charge this capacitor and then multimeter will show off. Cathode, red lead, anode, black lead. It will show some reading and then it will return back to 0. And now first it will go to 0 and then it will display voltage. Yes, because capacitor will discharge through the multimeter. Now it will show indication. In this time when it was showing indication, that time this capacitor was charging. In one side VCC rectifier it will show 0 and then voltage. Normally when we test diode will give directly 0.5 volt from OL, open loop, to 0.5 volt. But in this circuit, due to this capacitor, first it will show 0 and then 0.5. In this condition, if I will connect here, red lead at cathode, black lead at anode, we will see some values and then meter will go in OL because this capacitor is now charged. This is open circuit and this is open circuit. So that is reason reading and then open. And in forward bias, first it will discharge this capacitor and sometime it will not discharge. If this capacitor is already discharged, that time we will not see 0 before. We will see directly 0.45. Now I will use 400 volt capacitor here. Now I will install this 400 volt 5.6 microfarad capacitor and now we will see the response of the circuit. If the IC is good, this 400 volt capacitor will work normally. But in case the IC is bad, that time we will find the same voltage here on this capacitor. Another point, if we connect a capacitor in reverse polarity at just only around 10% of the rated voltage, the capacitor will blast. because these are polarity sensitive. Let's see the voltage value now. Because it is 400 volt capacitor, now it will not discharge the charging current. Now we have 325 volt, 334 volt here. Now we have 324 volt on this capacitor. That is the reason when this IC was damaged, it was not making load, because this time I removed IC. This IC is not present, and this capacitor will obtain the maximum allowed rated voltage of the circuit. Now I removed this IC, I removed the original value capacitor, and I installed higher rated voltage value capacitor, that is 400 volt capacitor, and it charged at same voltage value of this capacitor. Before this, the original capacitor, its internal dielectric was producing resistor due to leakage, but this 400 volt capacitor is now blocking voltage, and we are receiving approximately 325 volt here. I hope this video is informative for you. If it is good, give a thumb up. If you have any question, please write in the comments. Thanks for watching. Assalamu alaikum wa rahmatullahi wa barakatuh.